thank you again, Becky, for having me here today. I really appreciate it. And you've done a tremendous job of organizing this conference like you did last year. I would really love the setup of having a single plenary session. It's really terrific to be able to grab everybody in the same room all together and be able to have these conversations. When I was a young child, I used to go and visit my family in Ireland quite regularly. And I could trace my passion, as my colleague David calls it, being a passionate advocate of aerial imagery. It can be traced back to this image of my family's farm in Ireland. It's a picture of my aunt and uncle's farm where they have a dairy farm. Their milk goes into Perryville butter products that you can buy here in the U.S. And I used to sit and stare at this image day in and day out. Breakfast, lunch, and dinner sat right above their kitchen room table. And I was just absolutely perplexed at being able to see so many different aspects of the family farm compared to the traditional terrestrial perspective that we all have standing on the ground. What did we do before the advent of the aircraft, though? Folks like Alfred Ruger would go out there and get contracted by chambers of commerce and real estate agents in order to draw these oblique perspectives of cities and towns. But that's the big issue, is that they were drawing this in order to attract people to come in and move into these towns. So as a result, they're highlighting the positive aspects of the cities. So you can map, you can lie with maps. It's very easy to do. And even in the UAV industry, where many of us are going out there collecting NDVI imagery, if you don't know what you're doing, you can represent that NDVI map in a completely incorrect way. If you don't know how to stretch a histogram and know some baseline statistics, you could be passing along the wrong information to the farmer. And they might be utilizing that information to apply too much fungicide or too much fertilizer. And as a result, you might be creating some water quality issues. But I digress. After the advent of the aircraft, the USDA in the 1920s and 1930s started flying black and white aerial imagery all across the country. And this started removing a lot of the bias from a lot of the old cartographers that were introducing that bias into the development of their oblique images. The issue is, though, is the accessibility of that data was so limited. In order to access it, you would have to go out to map and imagery libraries, and if they didn't have hard copies of those data sets, then you'd have to track down where the film canisters were and have that film scanned and developed for you. A very expensive, very tedious process. It would probably take weeks, if not months, for you to be able to get that data into your hands. Then the 1990s and 2000s happened, and everything was great. All of a sudden we had CDs and DVDs, and you could burn digital ortho quarter quads onto these media sets. And then the internet happened. You could start downloading DOQQs via FTP, and all was good. And then Google Earth happened. And all of a sudden, aerial imagery became a lot more available to the general public. You no longer had to be just a GIS person utilizing Esri software or whatever software package you were using in order to access those DOQQs and the imagery containing them. And then Google Earth invented the timescale slider, so you could go back in time and look at historical imagery. Great thing. But the main issue with Google Earth is that you have this huge latency issue. And this still happens today. Even in my own neighborhood, the imagery dates back to 2012, and my neighborhood's almost complete, and it's still under construction according to Google Earth. And this is why UAVs were invented in the first place, to be able to help address this latency issue. There's many photogrammetry contracts that are out there. These are just a select few that I came across on the internet from 2014, 2015 time frame. Now, I've highlighted many of the Department of Transportation contracts that are in there. And I did that because I want to accentuate the fact that most of the photogrammetry contracts that happen within the United States is due to the need for capital improvement and infrastructure mapping. It's all driven by anthropocentric activities throughout the U.S. And that's where most of the budgets come from, to collect aerial imagery from the traditional market. And it's all being done by these guys. Many of these guys are actually here amongst you. Keystone Aerials, Surdex, Wolpert, the list goes on and on. So as UAV service providers, you're not only competing against other UAV service providers, but you're also competing against the efficiency that these guys have to offer with large million-dollar sensors like these. The Vexel Eagle, the Zeiss Intergraph TMC, which Lewis knows a little bit about, the Leica AES-40, you can go out there and acquire tremendous amounts of data with these. These are the types of sensors that are being used on the USDA National Agricultural Imagery Program, which is, to date, one of the largest acquisition programs in the U.S., covering typically 1/2 to 1/3 of the entire U.S. a year. That's a lot of data. And yet here we are with the UAV platforms. So how do we bridge the gap between what manned and unmanned is able to do? We're restricted to flying in, as you know, rural areas, mining operations, natural resources, for the most part. But this is where the money is at, in the infrastructure and capital improvements. If you have a Section 333 with a blanket COA, this is essentially the geometry as defined on the right-hand side. You're to remain 500 feet away from non-participating persons, vessels, vehicles, and structures. What does that mean when you do a little geometry? Well, Pythagorean theorem dictates that it's 458 feet below the native perspective of the actual UAV. Take that, square it, multiply it times pi, and that's 15 acres underneath your UAV. In my neighborhood, that means that you need to get written consent from 70 households if you were to just take a VTOL system and stick it straight in the air without it having moved around at all. So there's a lot of changes that need to happen within the FAA environment, I think, in order to make things happen a little bit. I'm from Alachua County, Florida. If you were to go to the University of Florida, you'd hear them call us ACRs. I'm a native. ACR is a derogatory word, basically saying that you're a little bit of a redneck, because we're all Floridians, we're in the South. But if you were to go out there and acquire aerial imagery with a manned system in Alachua County, you wouldn't have any issues whatsoever. You'd be able to go out there and almost do it the next day if you wanted to. With the UAV, when you start taking the 333 and introducing it into GIS, you take the road layer network, apply a 458-foot buffer on there for a 200-foot COA. That reduces your flyable space by 46%. You take urban areas, commercial areas, that's going to reduce it by an additional 6%. The 5 nautical mile radius around the controlled airport, that is Gainesville Airport, reduces your flyable space by 10% with your 200-foot COA. Beyond line of sight rules with timberland areas. We're a very forested area. Gainesville, Florida is considered Tree City, USA. We have tons of trees. That decreases your flyable area by 46%. You take all these together, merge them in GIS, and reapply an area calculation, and you're left with only being able to go out and fly 28% of the county. Significant changes need to be made in order for us to bridge the gap between manned and unmanned systems. This is the comparison. So this brings me to a list of grievances just based upon my experience having worked in the manned system and then also working in unmanned for the past about year and a half. And even with a 333 and a 200-foot COA, the world is not your oyster. You still cannot go out there and fly data wherever you want. And as Colin mentioned, there's a lot of people that are operating in the gray area right now. But for companies like Altavian and other companies that are actually following the rules and hiring pilots, we are putting our employees at risk when we tell them to go out there and fly projects where they could potentially get fined or get their licenses taken away by the FAA. It's all well and good for the mom and pop operations that don't have to adhere to those rules and regulations. They don't mind losing their own pilot's license. But for us, we have to think about our employees. Another pet peeve of mine that I've heard a lot is real-time kinematic on UAVs. In my personal opinion, RTK on UAVs is a little bit of a gimmick. And the reason for this is because I have tremendous amounts of experience post-processing kinematic data for the ASPRS sensors. If you ever get any data gaps that occur within your kinematic GPS, you have to interpolate what those positions are. The only way to ever really do that and establish a good a priori solution for your air triangulation bundle adjustment is to be able to post-process that data. And oftentimes it's best post-processed by establishing a base station or utilizing a port network. Are you going out there and touting the fact that you can go out and do direct georeferencing with your UAV? Well, if you're going and attesting to positional accuracies with your system, you better be going out there and utilizing some survey checkpoints as well. Because every single project is different, and you can't just take the hardware specifications of a UAV system and attest and apply those accuracy standards to a project without checking and validating it. Which brings me to my next point. Ground control points are not the same thing as checkpoints. They're two different things. I see many people going out there and using the same ground control points that they've utilized in a bundle adjustment solution, put it into Pix4D or PhotoScan, whatever it might be. And then they go back and reuse those same ones and calculate a root mean square error off of those same ground control points. You can't do that. It doesn't work. And that's why ASPRS has accuracy standards. They've been developed for a reason. So please use them. If you don't agree with them, then get involved with ASPRS and make some changes. Maybe we need to define some accuracy standards that are specific to UAVs. I think they've done a really good job in extrapolating it to be able to apply for smaller size project areas at higher resolutions. You're able to utilize the most recent iteration and look up 3-centimeter GSDs in there. So they've been very forward-thinking when they developed the most recent issue. My name is Brian Murphy, and Altavian is exhibiting at booth 50 over there in the corner. If you want to swap out your lander, come by and see us. And we'd love for you to swing by and have a conversation. Thank you so much.